1 minute.
Morning.
Morning. Did you guys revise yesterday's class?
Yes.
Yes.
Nice, very nice. Let me share my screen. Good. So today we will start with a fresh mind. We will start with hypothesis testing. 1 minute. Hmm. Okay, so we will try to understand hypothesis testing using this question as an example. Okay, so what the question is? Question is that let's say there is a manufacturer of bulbs. Okay, what they do is they manufacture bulbs, and then let's say they supply it to other branded companies. So for example, what Philips or any other big company do is that they don't manufacture the bulbs themselves. They contact with the local manufacturers, check their quality, and if the quality is adequate, they will put their own brand name on those bulbs and then they will sell it. Okay, so this is a very common thing, that the companies do. Now imagine you are working as a, as a manager in Philips, and your job is to kind of, check the quality of these bulbs that the local manufacturers are, producing. And if the quality is good, then uh, you will have a contract with them. Otherwise, you might not have a contract with them. Right? So the problem statement is very simple. We need to check what is the quality of bulb is. Now, what will happen is in real life, I will go to that manufacturer and I will talk to him. I will look at his facility and all of that, like what material he is using, how big the facility is, how much it can produce in a month, and all of that. Then on top of that, I will see, and then on top of that, there will be a few things that the manufacturer will tell me. That, for example, manufacturer will tell me that maybe the bulbs that he is producing, according to him, like what he's claiming is that on an average, if you will use that bulb daily, it will work for 500 days, right? Why we are talking about like for how long the bulb can work, because that kind of shows the quality of the bulb, right? Let's say Philips, just like any other brand, will give you some guarantee that let's say if the bulb will fuse within 1 year, then they will replace the product, right? So if the average life itself is 200 days, 300 days, right? Then they're gonna end up replacing a lot of bulbs. So uh, so now the manufacturer is claiming that the average life of bulbs is 500 days, but I cannot just take it on a face value, right? Maybe the manufacturer is lying, right? Maybe manufacturer feels that it is 500 days, but maybe it is even lesser than that. right? So this is something that we want to check, right? So let's start with that. Is the problem statement clear to you guys? What we need to do? We need to check whether whatever the manufacturer is claiming, right, that his bulbs works for have an average life of 500 days, whether that is correct or not. This is what we need to check. Okay. So let's start with this. Let's start with what we know. Right? What is given to us? We know that the claim from manufacturer is claim of average bulb life from manufacturer is 500 days. This is what is being claimed. It may be correct, may not be correct. Okay. Now, so let's call it maybe mu C, right? This is the average life which is being claimed. Now let's assume the actual average life of bulbs is something, let's say, I don't know what it is, right? So I'm going to give it just a variable, mu A. Okay. So what is being claimed is mu C, that is 500 days. And what is being actual is mu A. Mu A represents the actual average, right? Now, what are the different possibilities from your perspective? What are all the different things can happen from here? What are the scenarios?
So since the standard deviation we have it,
Mm-hmm.
okay, so we can say mu claim is equal to mu average.
Okay. Mm-hmm. That
That
is
is
one
one of the
possible,
possibilities. Yeah,
right? What is the other possibility?
it can be less than that.
It can be less than that, right? So we in general take two cases, although there are three cases which are possible, right? One case is, your mu actual is greater than what is being claimed. Your mu actual is same as what is being claimed. And one is mu actual is less than what is being claimed. Okay, but in general, we are gonna club these two together, let's say. Because as long as the average life of bulb is greater than equal to what is being claimed, I'm fine, right? The scenario where I'm not fine is this one, where the life of the bulbs is less than what is being claimed, right? Then the product is of inferior quality. So what I will do is I will write down these two cases which are possible. Case one is that your mu actual is same as what is being claimed, right? It means that whatever the manufacturer is claiming that the life of the bulbs is 500 days, that is correct. Okay. So, which means actual mean is same as claimed mean. Okay. Second scenario is your case two is when it is actually less than what is being claimed. That is your actual mean is, actual life of bulb is less than the claimed mean. Okay, these two possibilities are there. Now, the first possibility where we assume that the things are equal. Okay, the whenever we assume that there is no change, the things are equal, right? Wherever we have this equal to sign, out of the two cases, right? The case where I will have the equal to sign is always called null hypothesis. Always. The equal to one will become null hypothesis. Okay. And the other one will also become, will always become alternate hypothesis. Okay. Always and always the equal to one will be null hypothesis. The other one, it can be of greater than or it can be of less than, will become alternate hypothesis. Right? This is, we need to follow as a ground rule always. There will not be any case where this will not be true. Equal to will be same as null hypothesis. The other one, whether it is of less than or it is of greater than, will be called alternate hypothesis. Okay. Now, out of these two possible cases, obviously, one of the case will be correct. Either case one will be correct, that whatever is being claimed, that is correct, or the second case will be correct, that the actual will be less than what is being claimed. Okay. Now, how should we check this? How we should check which case or which hypothesis okay, how should we check which hypothesis is correct? That is the point now. Now, let's say I take a sample of 10 bulbs, right? And the average came out to be, let's say, 495 days. If you will take a sample of 10 bulbs and the average comes out to be 495 days, what will you say? Is the average less than what is being claimed, or is it same as what is being claimed?
Less than.
Less than.
Less than what is claimed? But can it not happen by chance?
Yes.
Yes.
Right? It can happen by chance also, right? Just
Yes.
because, let's say, if I will say that, the average height in India is, let's say, 160 centimeter. Does that mean that, and let's say this is the truth. I know that this is the case. But if I will randomly take 10 people, does that mean that it will always be equal to 160 centimeter?
No.
No, right?
No. Sometimes it can be, sometimes.
Sometimes it can be more, sometimes it can be less. So the point being is, even if I have taken 10 bulbs, even if I have taken 10 bulbs, just 1 minute. Yeah. Even if I have taken 10 bulbs, and let's say the average come out to be 495 days, even then I cannot be 100% sure that, or I'm not sure what percent I will be sure that it is less than 500 days. Maybe I'm 50% sure, maybe I'm 70% sure, or maybe I'm just 10% sure. Okay, so this is the problem. I think we all will agree that we are not sure that whether it is actually 495 days or not. But what if I will, so I don't know how much sure I am that it is less than 500 days. Let's say I'm X% sure, right? I'm X% sure that mu actual is less than what is being claimed in this case. Okay, it can be 10%, it can be 50%, it can be 80%, or it can be 100% also. That I'm 100% sure that it is based on this, that it is less than claimed. But let's assume it to be X%. Now, if instead of doing this, I had taken 100 bulbs, and let's say that average came out to be 495 days. I'm not doing both. I'm just telling you, okay, let's say if you had done that, if you had taken 100 bulbs instead of 10 bulbs, now let's say you are Y% sure. You are Y% sure that mu actual is less than what is being claimed. Now tell me, between X and Y, which one will be bigger? Will X% be bigger than Y%? Or X% will be same as Y%? Or X% will be less than Y%, right? Before you answer this, look at this slide. Try to understand what the question is, right? Think of an answer and then tell me. Out of these three possibility, 1, 2, and 3, which one is, according to you, is correct?
First case.
Okay, first case. Let's say
Yeah,
we have
because
one vote for this. Okay.
Third.
Yeah, tell me.
Third.
Third one.
Third. Third.
Third. Okay, why first case? You were explaining something.
yeah, first case is more than Y%.
Uh-huh. Uh-huh.
Because Y% that has more samples in it.
Right. So
So
in which case you will be more confident on your number?
if we have more samples, then we'll be more confident that Y% is correct.
Right, right. So Y% will be
Yeah.
more than X%, right?
Yes, yes.
Logically, this makes sense to us, right?
Yeah.
Right.
Sorry,
So,
and my answer is third, not the first one.
okay, sure. Right. So it means that if I will go logically, right, this one makes sense to us, right? And this is correct also. When you will have a bigger sample, I will be more confident that it is actually far away from 500. The actual average is lesser than 500. Right? But again, I'm not sure, like this I know, but it can be the case that maybe this is only 15%, that here I was 15% sure that the average life of bulb is less than 500 days, and maybe here, because the percentage is more, maybe I was 19% sure. Now if you are 19% sure that the average life of bulbs is less than 500 days, will you go and say that you are lying? Will you go to the manufacturer and say that, okay, you are lying about your bulbs?
No,
No. Why?
because like some of the bugs gonna be like defective, I guess. Like there can be some irregularities.
Mhm. Right. So the thing is that, like, we need to be more confident before we can confront any person. Right? 19% is not a very high probability, right, of, let's say, being sure on something. You guys agree? If I will say that I'm 19% sure this guy is stealing, will you go ahead and hang that person? No, right?
No,
19% is a very low probability, right? So we need to be, obviously, right, a little bit more confident before we can accept and reject the claims, right? But will Y% will be more than X%? The answer is yes. Will this Y% be sufficient to go ahead and say that no, the manufacturer is lying? That I don't know, right? Because I don't know these percentages. All I know is Y% will be more than the X%. Is this point clear to everyone?
But the company itself hasn't informed, right? Like, what's their basis on claiming that it's equal to 500 per average,
It can be anything. Let's say,
basis
for
on what
example,
number of samples?
right. Let's say, for example, maybe I'm just saying that I have seen it. I'm confident on my thing, right? Or he might say that I have done some experiment, or I tested it from third party vendor, right? He can say anything to support his claim.
Before solving the problem, I mean, is it not necessary to get that information?
No, like for
Okay.
example, you are the person, you are the manager, I am the manufacturer, right? You came and I claimed it to be 500, and you asked me, okay, how come you are saying it is 500? I said, I know that. I know that. I've worked with a lot of people. I supply it to many companies. I know that,
Okay.
right? Because in general, this is how people talk in India, right? So,
Yeah.
yeah, so it can be the case that maybe he doesn't have a strong backing of what he's claiming, but he's just saying that I know that, right? So it is on you to test it. Okay.
Yeah.
So, so I think what we are being able to establish from here is two things mainly, I believe, right? If I have to write it down, right? From the previous slide, like from based on this discussion, I believe that we can say that the bigger the sample that we have, more confident we will be on our number, on our average or on our number. That is one thing. The second thing that we were able to like kind of establish from the previous discussion is that yes, it will be bigger. When we will take bigger sample, your confidence will increase, right? But I don't know whether I'm still confident enough, right? I don't know these values, whether it is 19%, whether it is 50%, whether it is 80%. All I know is y is greater than x. That's it. So I know that taking more sample will help. Okay. But how much it has helped, I don't know. In the absolute number terms, I don't know. Right. So the second problem, like the first thing is, if you will take bigger sample, you will be more confident on number. But the problem is we don't know exactly how much confident we are on a number. Right. So we know that x% will be less than y%, but what will be the values of x and y? We don't know. Okay, so let's try to understand it using an example. Okay, what we will do is, right, to find this probability, what we will do is, let's assume, okay, let's assume that our null hypothesis is correct. Let's assume our null hypothesis. What was our null hypothesis?
Our exam, 500
Average
bulbs are,
claimed average.
yeah, claimed average is equals to assumed average.
500.
Right, exactly. Right. So, yes, the first case. Now, the main part here is that we should not forget throughout our discussion from here is that I am assuming it to be correct. Okay. I don't know it is correct, like, because that's what we are trying to check. I am assuming it to be correct for now. Okay. So I will be solving this question, assuming our null hypothesis is correct, which is whatever is the actual is same as whatever is being claimed is equal to 500 days. Okay. So I'm assuming my null hypothesis is correct, and whatever is actual is same as what is being claimed. Now, what I will do is I will take the biggest sample that I can take. Okay. Let's take the biggest possible sample. Why I'm taking the biggest possible sample?
Because it's gonna give us like more normal distribution or approx to a normal, like the real mean
Right.
as the like
Because, yeah, right, more or less you are right that the bigger the sample will be, more confident we
Confident.
will be on our number, right? Like for example, here I said that if you will have 100 bulbs, you will be more confident on your number as compared to if you will have 10 bulbs, right? So I'm saying let's take the biggest sample which is possible, right? Now, obviously, I cannot take 10,000 bulbs, 50,000 bulbs, because the more the number of bulbs that you will take to test them, the more it will require the electricity, the money to test all of that, right? So I don't want to take a very, very big sample. Like if you'll ask me why not 50,000 bulbs or let's say 100,000 bulbs, that will be not possible because that will be very expensive. So let's take the biggest possible sample, which is in this case is equal to 50 bulbs, right? Right. Again, later on, once we will have understood the question, we will try out different values. Let's say if it was not 50 bulbs, it was 500 bulbs. What if it was only 10 bulbs or it was only 5 bulbs, right? So we will discuss all those scenarios. But to start with, let's assume that we have taken 50 bulbs sample. Okay. So we have taken one sample of 50 bulbs. And then what I'm going to do next? I'm going to calculate the life of these bulbs, right? So one bulb life, let's say, was 490. Another bulb's life was 500, 510, 495, 498, 523, right? So I will have how many such values? How many such
50.
values will be?
three, three.
Right. 50 values will be there. 50 such values will be there. Okay, because there are 50 bulbs. Right? Now
Did
from
we
here,
also assume the value or like we have to measure it individually for each one?
no, we have to
Isn't
measure
it
it.
gonna be same?
No, we have
If
to
we
measure it. This is the experiment that you are doing. So you
okay for
have
each
taken,
bulb we have to measure.
yes.
Okay. If the sample is like big, like for example 1,000, how can we like measure for each bulb then?
Right. So in that case, you will not take the sample of 1,000. Then it is not possible to take that big of a sample. That's why I said, let's take the
Okay.
biggest possible sample, right? So I
Oh,
want to take a very big sample. Like I would like to take 1,000 bulbs. I would like to take 10,000 bulbs, but that is not possible, right? So whatever is
okay.
possible, that I'm planning to do. Okay. So let's say I have taken 50 bulbs and I did the experiment. Okay. These are not the made up values. These are the actual value for each bulb. One bulb, let's say 490, 510, 490, 498, like all these different values are there. Okay. So this This is not based on any assumption. This is something which has happened. Okay. And then average for these values, came out to be 490 days. Okay, the average came out to be 490 days. Now from here, what I want to calculate is how much confident I am that it is actually less than 500 days or it is not happening by chance, right? Because by chance it can also happen. As we took an example of, let's say, height. If in India, the average height is 160 centimeter, it can happen that if I randomly select 50, 100 people, right, and that average came out to be 154 or 166. Right? So I want to check what are the chances that this value can come by chance. Okay, so our question will become something like this. What is the probability? What is the probability that a sample of 50 bulbs will give values, will give average value, right? What is the probability the sample of 50 bulbs will give average value which are as extreme as 490 days? Or in other words, I'm asking 490 days given the population averages (500) and population standard deviation is 25 days. Okay. So what it is asking you is, what are the chances that you will see a average value to be less than equal to 490 days if my population average is 500 days and my population standard deviation is 25 days. Okay. Have we solved similar questions before?
Yes.
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 If you look at it, this is nothing but a question of central limit theorem. Using central limit theorem, now what I will do is I will be able to make a graph. Okay, let me show you that first. If now my question to you is, if I had taken, okay, if I had taken multiple samples of sample size 50, right, then the averages of those samples will follow a normal distribution. Is that correct or not?
Yes.
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 Right? What will be the average of that that distribution?
500.
Mu CLT,
UCLD
Me
equals
CLT is equal to what?
mu population.
New
Mu
pop.
new
population.
population by root n.
No, it is
That's
mu
standard
CLT is
deviation.
equal to mu population, right? Which was 500. Sigma CLT?
Sigma population by square root n.
Sigma population by square root n, that is 25 divided by under root 50,
15.
which is, let me calculate it.
3.54.
3.54. Okay. Let's, for simplicity's sake, we will take it as 3.5. Okay. Now, what I can do is that if I had taken multiple samples of sample size 50, then the means of those samples would have followed a normal distribution with mean equal to 500 and standard deviation is equal to 3.5. So I will make it 503.5, 507, 510.5. Okay. On this side, it will be, let's say minus sigma. So 496.5, 493, right? And I believe 489.5. This is the distribution that you will get if you will take multiple samples of 500, right? This will be a distribution that you will get of their means, given that, right? Assuming the population mean to be 500 days. This is my assumption. Okay. I am assuming it to be true. Assuming this to be true. Okay. If this is correct, then this will happen. Okay. Now, what was the average that we got? 490, right? We got this average. So if I have conducted the experiment multiple times, then this is the distribution that I will get. Though I have conducted it only once, and it is 490 that we are getting. So 490 is somewhere here. And we want to know, well, like what are the chances that you will get values as extreme as 490? So from like here the extreme will be the values less than 490s, less than equal to 490. Right? Because that will be an extreme value. Similarly, if I was on this side, then the values greater than this will be extreme values. Okay. Then, yeah. So this is 490. And I want to find out what is this probability? What is this probability? Can you calculate it? What is this probability?
0.26.
0.26% or 26%?
0.26%.
Okay. You guys, first of all, if you don't have pen or a notebook, please bring pen and notebook because we will be solving a lot of questions today. So take your time, bring pen and notebook, and then we will discuss this.
Sir, this 490 you just took, like, for example.
Right, yes. Let's say I have conducted this experiment and the average came out to be 490. Then what would I have done?
I didn't understand this statement, like average value which are as extreme as 490 days.
It means that by extreme here, I mean that let's say if you are standing at 500, right? If I'm expecting my value to come out to be 500, right? If I was expecting it to come out 500, then any value which is far away from 500 will be taken as extreme, right? So the extreme can be on the lower side as well. The extreme can be on the upper side as well. Right? So when I say the values which are as extreme as 490, because 490 is on this side of 500, right? These values I will not call extreme. Why? Because it is closer to 500. The values which will be extreme is the values which are far away from 490. Okay, so more or less what we are trying to check is what are the chances that we will get values average less than equal to 490 days. Okay, if you don't want to, let's say, call it like extreme values, just reword it as what are the chances that we will get values which are less than equal to 490 days.
I'm also getting 0.3%.
Nice.
So this is for like case one. 0.23% is for
Mhm.
case one. Here,
Mhm.
like new CRT is equal to new population 500. Here
Mhm.
for the case one is 0.23. So we have to
Mhm.
like calculate for case two also
No, no,
every
okay,
time.
we will see that. Like we will see that. Not exactly. Okay, now let's try to solve it. Okay, first of all, the first question is, should I be using T distribution or Z distribution?
It should be T.
Z
Z
because
distribution.
we have standard deviation given. It's
Right,
known.
exactly, right? Because the standard deviation of population is given to you. It means that I'm not making any assumption about standard deviation of the population, because I'm not making any assumption about that. There will not be any errors that I will be introducing. That means that I need not to correct for any errors, right? So I will be simply using Z distribution.
Sample size greater than 30.
That matters on, yeah, that is one thing, but the question comes into picture only when the your standard deviation of population is unknown.
Okay.
Right? If standard deviation of population is known, then it is always that distribution. Okay. But yes, we can remember it like anyway. If it is greater than 30, it is always that distribution. You can remember it like that also. So Z value is nothing but Xi minus mu. Always write formula again and again so that you will remember it. Xi minus mu divided by sigma. Xi is 490 minus mu, that is 500, divided by sigma, let's say that is 3.5. So 10 divided by 3.5 minus 10 divided by 3.5. What is the value?
2.82.
Minus 2.82.
Minus 2.82. Right? Then the next part will be, I will go and I will check for minus 2.82. What is the probability that we have? Minus 2.80, 81, 82, right? 0.0024. 0.0024. The probability associate, sorry, this was probability only. The probability associated with it is 0.0024, that is 0.24%. Should I do 1 minus p?
It is 10 divided by 3.5 is 2.8 0.0485. So it will come to 0.002. That is 0.22%.
I'm getting minus 2.83.
That's fine. More or less, we are correct, right?
Yeah.
82, 83, 81, right? Approximately the probability will be this much only, right? Approximately.
Yeah.
Maybe you will get 0.2, maybe someone will get 0.3, right? But let's assume the value is minus 2.82, okay? And the probability value came out to be 0.24%. Okay, is it a very high probability? First of all, okay, first question is, should I do 1 minus p or not?
No, we are not
What?
checking for the negation. We are checking till that one. So it is the probability.
Could be
Right.
extreme far away values, so we won't be deducting it because Z values give us the lowest values.
Right. The Z table gives you probability of
Till there.
less than,
Because it's less
Yeah.
Right.
than, so we don't have to.
Exactly. Right. And whenever I want to get the probability of greater than, I will be doing 1 minus p. Okay. So the probability that you will get value less than equal to 490, right? The probability that if I will take a sample of 50 bulbs, then the average of those 50 bulbs life will come out to be 490 days. That chances are 0.24%, like less than even 1%, right? So either I was extremely unlucky, right, that the actual like the actual average was 500, and I was extremely unlucky that I got 490 as an average. Or what is second probability? Second case?
The average is might be wrong.
Yeah. The second case is that the population average is actually not 500, because this curve that I have, the red curve that I have made assuming my null hypothesis to be true, right? If my null hypothesis is true, then this red curve will also be true. If the red curve is true, then the chances that I will get an average of 490 or less is just 0.24%, right? So either I was extremely unlucky, or this red curve that I have made based on the assumption that the population average is 500, that assumption is not right. Okay. The population average is most probably less than 500.
Can you explain again, like how
Yes,
we
yes, I
define
can.
0.24% probability?
How we got 0.24%?
Not
Is-
got, like how you define that solution? I didn't get.
Okay. So the probability we got 0.24%, right? So if I'll ask you, what is this probability means? Like what is 2.4% here, 0.24% here? What is
The
your understanding of
probability
that?
of getting bulb with a lifespan of 490 days, 0.24%.
No, I want more
Chances
accurate.
are,
Less than 490.
No, I want more accurate answer than this. Anyone else wants to give it an attempt? What do I mean by 0.24% here?
The probability of sample mean is less than like 490 is like
My chances are
0.24.
0.24% of getting less than 490.
A little bit more accurate answer. Like what you said is right, but not the whole statement. What will be the whole statement? The whole statement is, if I will take a sample of 50 bulbs, that is the important part. This 0.24 is associated with a sample of 50 bulbs. Okay. If I will take a sample of 50 bulbs, the chances that I will get an average value of less than or equal to 490 days, those chances are 0.24%. Okay. Less than even 1%. So it means that if this distribution is correct, if this assumption is correct, then the experiment that I have conducted, right, this experiment will lead to an average of 490 days or less than value than that. Those chances are only 0.24%, right? So either I'm extremely unlucky, right, that I got a value which is close to 490, or maybe the assumption that I have made about this distribution, that it is centered at 500, that assumption is wrong. Okay.
And you didn't get 490 days, 490 days, like bulk working for 490 days.
Sorry.
I didn't get that thing. What is 490 days?
490 days is the average that we have got after doing the experiment. Okay. We took 500, we took 50 bulbs, right? We plugged them in the socket and we measured all the individual values, and then we took an average of it. That average is 490. Okay. Right. So the English for this, like the conclusion will look something like this. Okay. Let me write it down. Maybe that will make it a little bit more easy to understand. If mu actual is same as what is being claimed, like that is the mean, that is the mean life of bulbs is 500 days. If this is correct, right? If mu actual is same as what is being claimed, that is the mean life of bulbs is 500 days, then chances of us getting a sample mean less than the chances of us getting a sample mean of less than and equal to equal to 490 for okay, for sample of 50 bulbs I'm saying this. So if mu actual is same as what is being claimed, that is the average life of bulbs is 500 days, then chances of us getting a sample mean of less than or equal to 490 is just 0.24%. If this assumption is correct, right, then the chances of we getting a mean of 490 or less is just 0.24%. All right. Now,
So this is the correct way to answer like this question. We have to answer this way whenever
right,
asked.
right. This means that most probably the assumption that we have made about mean of the population of mean of the population, that is is incorrect. Okay, the assumption that we have made is incorrect. That is mu actual is not equal to 500 and mu actual is actually less than 500 days. Okay, we are not saying it is 490 days. We are not saying it is 495 days. I'm not saying it is 485 days. I'm not saying what is the actual value. All I'm saying is that it is less than 500 days. It can be 499, it can be 498, it can be 495, it can be 492, it can be 490, it can be anything less than 500 days. Okay, but whether it is what is the exact value, that I don't know. Okay, and then from here we conclude that
But the probability that we got less than 490 is very less, right?
right,
So that
yes,
it means that the probability greater than 490 is higher, isn't it?
right. You're right. You're right. The probability that you will get a value, right, less than equal to 490 is very less, right? But you still got that value, right? The chances that you will be getting a value less than 490 was very less. If
Yeah.
if the population mean was 500, but you still got that value, right? So it means that either you were super unlucky, right? Or that the assumption that you made that the population average is 500 days, that assumption is wrong. You got my point?
Yeah, man, what I thought is that mu actual is 500 only because the probability that we got less than 490 is 0.24%, which is less than 1%.
No,
So
no,
which
yeah.
means that
You're
99% are accurate.
right, right. You are
Um,
right. What you are saying is right, right? Assuming the population average is 500 days, right? I'm just
yeah.
saying if I had not conducted the experiment, right? If I had not conducted the experiment, then what I am saying is assuming the population averages 500 days, then the chances that a sample of 50 bulbs will give you an average of less than equal to 490 days, those chances were very less, right? Yes or no?
Yes.
Those chances are very less, but you still got a value which is 490. You got my
Okay.
point? You still
Okay.
got that value. It means that let's say what should I say? Uh,
Okay. I like what I understand from your
hmm,
statement is
hmm,
so there is probability that okay it is less than 500 even though
hmm,
it is 0.24%. There are chances there are some use cases where we got less than 500 that is around 490 or something
hmm,
though it is a lesser probability.
right.
I mean, is my understanding right?
I was not able to like follow it fully. Can
Okay.
you explain it again? Yeah.
Yeah, so less than 490 we got it's 0.24%, right, which is less than 1%. Okay, so the probability
Hmm.
of getting 500 is more. If we say if it is greater than 490, the
Hmm.
probability is more. But
Okay.
still, we got
Probability of what is more?
having the average life of more than 490 days.
Average life of what more than 490 days?
50 bulb, I mean, the sample of 50 bulbs.
The sample of 50 bulbs, not the population, right? Because this is
Yes.
this is what I feel where you are confusing it. That this
Okay.
490 is not. I'm not trying to check whether the population average is 490 or not. I'm not trying to check that.
Yeah,
Okay, I
we are
believe
checking the sample population.
right, right. I'm just taking the sample, right? That whether the sample can give me a less than value of 490 or not. Yes. Okay, continue.
Okay. So,
Uh-huh.
as you said, like it is less than 490.
Mm-hmm.
That is 0.24%. So there is high chances that there are some bulbs which can last less than 490, though it is a lesser probability. That's what we are trying to say. I didn't get that point, the last point.
Mm-hmm. No. Just 1 minute. Let me think of an example.
In the slide number 6,
Mm-hmm.
you go to that slide number 6.
Mm-hmm.
So what I thought is like, this mu a is greater than 500 is. That's what I thought. The last statement.
Yeah, right. I believe you are doing that because you are thinking it from like the graph that we have made, right? This graph that we have made, you are thinking it from population perspective. Don't think it from population perspective. This graph is not for population average. Okay.
Yeah, sample only. Yeah, I got that as a
Right.
sample only. Oh,
Right. So from this graph, like when I'm saying that the chances of getting an average more than 490, right? You're like 99%, right? Then you are
yes.
concluding from there the mu actual is going to be more than 500 days, right? Something like that you are doing.
Yeah, exactly. Yes, yeah.
Right. Which is the incorrect statement. What this is what I'm saying.
Okay.
You are mixing two things. Like
Mhm.
although you are saying that you are not, right? But in your mind you are mixing two things.
Okay.
The thing is that from this graph, I'm not trying to comment anything related to population. Okay.
Okay.
The only the only thing related to population about this chart is my assumption that the population average is 500. That is the only thing related to population in this chart. Okay. If
Okay.
my population average was 500, okay, again, if my population average was 500, then the chances that a sample of 50 bulbs will give me an average of less than and equal to 490 was very less. If this was true, then ideally a sample of 50 bulbs should not give you an average of less than equal to 490. It should not give you, right?
Okay.
Because the chances are very less if this assumption is correct, right? But what happened? What value you got? You got value 490. The chances of
Okay.
that happening was very low, but you still got that value, right? So it means that maybe my first statement that the chances of me getting a value less than equal to 490, the chances are very less. That statement in itself is wrong.
Okay.
That is a wrong statement. Okay. If it is a wrong statement, right, that what I'm saying is that the probability that I will get a value less than 490, that probability is very less. That statement is wrong. That statement is wrong.
Okay.
I'm getting a value which is less than 490. Okay, because that statement is wrong, right?
Okay.
The average will be less than 500 days. Okay.
Okay.
So what you are saying is you said that because I said the average value will be the chances that the average value come out to be less than 490 days, those chances are very less. That means that the chances that I will get a value greater than 490, those chances are very high, and that's why 500 is correct, right?
Yeah.
But I'm
Yes.
saying is you are missing one statement, like between these two statements. The one
Okay.
statement that I said between these two is that the first statement that I have said, that the chances of me getting a value greater than 490 is very high. That statement is wrong.
Okay.
Why that statement is wrong? Because I conducted an experiment and I got a value less than 490.
Okay.
Okay.
Even though the probability is 0.24%, you still got that value.
Right. If the probability was 0.24%, then me getting a less than value 49 less than equal to 490, those chances were very less. But it happened. It means that the
Okay.
chances are more. Right? This is the main part. It means that the chances are more that you can get a value of less than equal to 490.
Okay.
Okay? Because those chances are more, the average is not 500, is less than 500 days.
Yeah, understood now. Yeah. Thank you.
Okay. Does anyone else has any question? This is a little confusing. I know that part. So if you have any question, you can ask me.
So at what probability have we said that the assumption is correct? If you have to.
Very, very nice question. All right, I will answer that. Very nice question, Vinay. Any other question apart from that before I go to that? Okay, Vinay, I will answer that question. So, so we said if mu actual, right? Again, this if is a very important part of this whole statement. That if mu actual was equal to mu claim, then the average life of bulbs is 500 days, right? Then the chances of us getting a sample mean of less than equal to 490 is just 0.24%. It was just 0.24%. But we got a we got an average of 490, right? Let me add that statement also in between. Okay, let me add that thing somewhere here. Was is just two. So if mu actual was equal to mu claim, then the mean life of bulbs is 500 days. Then the chances of us getting a sample mean of less than equal to 490 is just 0.24%. But our experiment of 50 bulbs gave us average of 490, which means, sorry, just one. Which means either we were super unlucky or the assumption that we made which led to okay. Is it making more sense now?
Yeah.
Any question, anyone?
Sir, over here we were unlucky as in the bulbs, the bulbs were not up to the mark in that context, right?
No, no, no. Unlucky, it means that, let's say, for example, if the India's average height was 160, right?
Hmm.
And if I will take a random sample of, let's say, 10 people, right?
Hmm.
Is it possible that maybe the average come out to be 130? Is it possible?
Yeah.
Possible, right? Is it possible that might come as 100? Yes, possible, right?
Yes.
Everything is possible, but the chances of that happening are very low. So if you will get that value, it means that most probably you were very unlucky that you just got a group which was very short,
Hmm. Okay.
right? So that is a like so in this world, it is always possible to get some value, right? Even like everything is possible, right? So if the chances of something happening are very rare, and if it still happens, right, then either you were very unlucky, or that your assumption itself, right, that the chances are very low, that assumption itself was wrong. The chances was very high from the very starting itself.
So,
Okay.
but for this statement, having the average height of 130 is not an issue. But in
Mhm.
case of bulbs, having an average life less than 500 is an issue, right?
Right.
So unlucky, it means the same thing. Like the average life of the bulb is less than 500, isn't
Right.
it?
Right. But yeah, unlucky is that thing. Unlucky can be many other things. But here, when I say
Uh,
super unlucky, I didn't mean by that
okay.
the average life came out to be less than 500, and that's why I was unlucky. Maybe I was not unlucky. Maybe that manufacturer was unlucky, right? So this unlucky is not that. The unlucky is here is like the chances was very less, but I still got that value. That I'm talking about as being unlucky, or the assumption that we made that the chances was 0.24%, that assumption itself was wrong. The chances were actually very high from the starting itself.
Okay. So it could be some due to external factors that we got unlucky.
No, yeah, it can happen, right? Like there is a chance that manufacturer is not lying, right? And he got just unlucky that the bulb that I chose, right, were defaulted bulbs, right? There is a
Okay.
chance for that. But I'm just saying those chances are very, very low, right? Those are very, very low. So most probably he is lying. Most probably, I'm like 99% sure that he is lying and the average is less than 490 days. But am I 100% sure? Obviously not.
Okay.
Even if you will take, let's say, a sample of 50 bulbs and the average come out to be 300 days, can you, if you will ask me, can you give it in writing that it will not be 500 days? I will not give it in writing.
Okay.
All right. And everything is possible, but it's about chances, right? The chances that it is actually 500 days and I still got 490, those chances are very, very less. It can still happen, but the chances are very, very less, right?
Okay.
Because the chances are very, very less and it is still happening, it means that most probably the chances were not very less. The assumption that we made that the chances are less, that assumption itself was wrong.
Okay. Okay.
Okay.
Sir, did I miss anything? Like we were not finding out the average of 50 pulse, right? We were given that the average of 50 pulse is 490, and we found out the probability is 0.24 at the end.
Right.
But
Yes.
here we are saying in the reverse thing.
Right. Because we solve that question making an assumption. Okay. We solve that question not based on the truth. Right. This question that we have solved, the previous question that we have solved, is based on an assumption. What is that assumption? That the population average is 500. This is open for debate. The thing is that this is open for debate. Okay. So don't think that the population average is 500. I have solved this question assuming it to be 500.
Okay.
Okay. But when I solved it, I realized that if the population average was 500, then me getting a value of 490 was the chances was very less, right? It means that the assumption that I have made that it is 500, that assumption is wrong.
Okay.
Okay. We will try to solve. Just be with me, right? Just don't give up on this part, right? Just be with me for the whole class. I will take multiple examples. Like what will happen if I will increase the sample size? What will happen if I will, if it was not claimed as 500, was claimed as 495? We will try multiple things. We'll try changing things, and that will make things more clearer, right? So even if you're 70, 80% there, Just hold on to that. Okay. Now, like whatever I have written over here, right? Obviously, we don't write this much English, right? All we say is that because the probability is very less, mu actual is not equal to mu claimed. That is, mu actual is less than what is being claimed. And we will write one more line. Null hypothesis is rejected and alternate hypothesis is accepted. Okay. If I want to write it in a little bit more detailed manner, a few people write it as there are sufficient evidence. This is the language of stats here now. As there are sufficient evidence against the null hypothesis, we will reject the null hypothesis and accept the alternate hypothesis. Okay, you can write it in both the formats. In general, let's say if you're writing a research paper, for example, you will use something, a language like this. If you are doing it for yourself, this much is enough. And obviously, if you're doing it in a company, then maybe you would have to write something like very big like this to explain it to the other person. Right? Now, Vineet asked a very good question like a few minutes back. He asked that we are saying 0.24% is very less. And hence we are rejecting the null hypothesis. Right? Because 0.2%, 4% is very less, we are rejecting the null hypothesis. But at what percentage? Okay, at what percentage we will be rejecting the null hypothesis? At what percentage we will be accepting it? Okay, for that we use a threshold called significance level. Okay, so there's something called significance level. Significance level, we denote it using alpha, and in general it is taken as 0.05 or 5%. Okay, this is something you can take it as an industry standard. Most of the time it is 5%. In a few cases it is 1%, but in general these are the two values which is used. Okay, so when probability, the p value that you are getting is less than alpha, right? Or I can say that when the p value is less than 5%, then we reject the null hypothesis. Okay, when p-value is greater than alpha or when p-value is greater than 5%, then we accept the null hypothesis. Okay, so the threshold that we have is of 5%. If your probability will come out to be less than 5%, then we will be rejecting it. If the probability will come out more than 5%, then we will be accepting the null hypothesis. Okay, now do you guys want to take a break? After that, we can discuss more possibilities. Let's say instead of 50 bulbs, let's say if 50 bulbs had resulted in an average of 495, then whether we will be accepting the null hypothesis or rejecting the null hypothesis, right? Let's say maybe this is what we will try. Okay, so I'll keep on sharing my screen, this slide. If you want to go through it, you can, and otherwise I will see you guys in 15 minutes. Okay, after the break. Okay, we'll start in 30 seconds. Okay, let's start. Right. So, what happened was that we did an experiment, and based on that experiment, we took like 50 bulbs, and the value came out to be 490. Right. What if the value, let's say, if we had conducted the experiment, and the value might have come 495 days, right? So let's say we have 50 bulbs, and let's say in some other universe, we conducted the experiment, and the values that we got was 490, 512, 498, 506, and similarly, I have like other 50 values. Okay, and when I calculated the average, okay, let's say that average came out to be 495. Okay, now again, we will frame the question like this. What are the chances that a sample of 50 bulb, right, will give a average value of less than equal to 495 if assuming population average was 500 days and standard deviation was 25 days. So you need to solve this question. Okay, exactly same question, is just that this time we need to solve it for 495. Nice enough. Right. First, we will calculate your mu CLT, which will be equal to mu population, which is equal to 500. Okay. The second thing will be sigma CLT, which was sigma population divided by under root n. And we know that it is approximately 3.5, I believe, right? Yeah, 3.5. Now solve this question. Okay, now very nice, right? First, we'll calculate the z value. Z value is xi minus mu divided by sigma. Xi is 495 minus 500, and then by sigma, that is 3.5. So minus 5 divided by 3.5, which I believe will be half of what we got last time. 2.8 minus 1.41.
Yes.
Right? And the probability associated with this is, I believe everyone is saying 7.78. So let's say 7.78%. Okay. Now, what we need to check is, we need to check if our probability is greater than alpha or our p-value is less than alpha. What is the case?
Greater than alpha.
Greater than alpha.
Right? Assuming
Null.
alpha to be 5%. Okay. So because our p-value is greater than alpha, that is
Null hypothesis.
right. That is 7.78% is greater than 5%. We can say that null hypothesis is accepted or rejected?
Accepted.
Is accepted.
Accepted.
Right? That is mu actual is same as what is being claimed is equal to 500 days. Right? So it means that we do not have sufficient evidence to claim that the actual mean was not 500 days. Okay, we do not have sufficient evidence. This can happen by chance. Okay, so more or less, let's say if I will draw it, this is how it will look like. So more or less, this is how it is looking like. That the n that I have for both the cases, the first case that we took or second cases we took, for both n we assume it to be 50, right? And that's why mu CLT will be how much? 500. And sigma CLT was 3.5. Right? So if I will make the distribution, this will look something like this. I'm just showing you what is happening for both the cases. This is, let's say, 500, 503.5, 507, 510.5. This is 496. 0.5, 493, 489.5. Okay. The first question that we solved where we got the value as 490 was here. Like somewhere here. This was 490. And we said what is the chance that you will get a value as extreme as 490 or less? Those chances were very less. Those chances were very less. This is a very, very small probability, which was around 0.24%. Okay. In the second case, when we did the experiment, let's say in a parallel universe, right, it came out to be around 495. 495 is somewhere here. Right? And this can happen by chance. If this is the distribution, the chances of we getting this much is high enough that we cannot ignore. Right? This was around 7.73, I believe, right? 78. Okay, so if you are getting a value of 495, then there is enough chance that it might be happening. It is coming from the same distribution. Okay, that's why we are saying that 500 is possible. If I am getting a value of 495, then 500 is possible because 495 value can come. But let's say if I'm getting a value of 490, right, then chances of that happening is very less as compared to 500. That's why I'm saying that this is not possible. In this case, in this case, what we did was we said that mu actual is not equal to mu claimed, and mu actual is actually less than what is being claimed, right? And in this case, we said that mu actual is same as what is being claimed, which is 500 days. I don't have sufficient evidence to reject the manufacturer's claim. Okay, but in the previous case, I have sufficient evidence to reject the manufacturer's claim because chances of 490 happening was very less. Okay, so this is happening in a different universe. Let's say this is a parallel universe too. This is in a different universe this is happening. It is not like that I'm doing two experiments on the same manufacturer. No, I'm doing only one experiment. In one universe, I got a value of 490. In another universe, I got a value of 495. Let's say in a third universe, okay, let's assume that there is a third universe, the parallel universe, where instead of taking 50 bulbs, right, instead of taking 50 bulbs, let's say you took, I don't know, but let's say 200 bulbs. You took a sample of 200 bulbs. Again, there will be 200 values now, 490, 514, 507, 488, right? Similarly, let's say multiple values were there. How many values are there? 200 such values are there. And let's say in this case also, in this third parallel universe, the value came out to be 495 days. The average came out to be 495 days. Now you tell me whether we will be accepting the null hypothesis or we will be rejecting the null hypothesis. Okay. I'll add the same question from here. What are the chances that a sample of 200 bulbs will give average of 495 days or less if population average was days with standard deviation of 25 days. Okay, just like always. Let me first solve it here only. We will first calculate mu CLT, which is equal to mu population, which is equal to 500. Then we will calculate sigma CLT, which is sigma population divided by under root n, that is 25 divided by under root 200. What is the value if you guys have calculated?
1.77.
1.77.
1.77.
Okay. Then the next thing that I will do is we will calculate the z score, which is nothing but xi minus mu divided by sigma. Xi is 495 minus 500 divided by 1.77. So it is 5 divided by 1.77, that is 2.82 minus 2.82. Oh, this is coming very close to what we calculated earlier, right? So the p value associated with this value minus 2.82 is minus 2.800182. That is 0.0024, same value. That is 0.24%. Okay, it is coming 0.24%. Zero 0.24%. Now, our p value is obviously less than alpha, as 0.24% is less than 5%. This means null hypothesis is rejected or accepted?
Reject.
Is rejected. That is, mu actual is not same as what it is being claimed. So that is mu actual is less than 500 days. Right? See, now what is happening? Last time also you got the value as 495 with 50 sample. This time also you are getting a value of 495 but with 200 samples. So now because your sample size has increased, right? We started today's class with this. Now because our sample size have increased, we are more confident on our number, right? And that's why we are saying that, okay, if we are taking 200 bulbs and you are getting an average of 495, right? Then most probably the average is less than 500. It is not equal to 500. But if I had taken only 50 bulbs and then I'm getting a value of 495, then it means that yes, there are chances it can still be 500 days. I'm not very sure on this. Okay, so let's say if I'll just create a table of the things that we have tried so far. We had different sample size. Let's say we tried 2 different sample sizes. We got average value, right? And then we were able to do some verdict based on the p value. Okay, so in the very first case, we took a sample size of 50. What was the average value that we assumed in the very first case?
490.
490. Okay. Let me actually add one more thing. Let's add p-value associated with that experiment. And finally, I can add the verdict. When I took a sample of 50 and I got value 490, which is far from 500, right? I got a probability score of 0.24. The chances that a 50 bulbs will give me an average of 490 if population average was 500 was only 0.24%, and that's why I rejected the null hypothesis. I said mu actual is not same as what is being claimed. Actually, it is less than what is being claimed. How much it is, I don't know, but it is not 500 days. Can it be 498? Yes. Can it be 496? Maybe it can be 494. I don't know. But it is definitely less than 500 days. Then in a parallel universe, when we conducted the experiment, it came out to be 495. What if it was 495? Then the average will be around 7.7%. Now I don't have sufficient evidence. Right now we are saying that 495 is very close to 500, and that's why I'm not being able to reject null hypothesis. It means that mu actual is what is being claimed. I'm not being able to reject it. I don't have enough confidence to say that this is not true. So this is, I will assume it to be true. Then I said that, okay, let's increase the sample size. And let's say if I will still get the average of 495 in a third parallel universe, right? These things are happening in a different universe. Let's say in a third parallel universe, I took a sample of 200 bulbs. I got an average of 495, and I again got a probability value of 0.24%. Again, because the chances of me getting an average of 495 for a sample of 200 is very less if population average was 500. That's why population average is not 500. It is actually less than that. Okay, you have already seen the comparison of first scenario and the second scenario, right? This is the first scenario. This was the second scenario. Let me compare with the third scenario as well. How a third scenario will look like. Third scenario will look something like this. Now I know that the center will be at 500 and it is 1.77. Let's assume it to be 1.8. Okay, just for our visualization purpose, we will assume it to be 1.8. This is 500. 500 plus 1.8 will be somewhere around uh, 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 501.8, right? Which is, I believe, very close to this. Um, and then, right? So this is how much? This is 501.8. This is the, actually I did it wrong. Okay. The first one is 501.8, which I feel that will be somewhere here. Somewhere here. 501.8. The second one is 500 and what will be the second value on this side? What will be plus 2 sigma?
503.6.
3.6, right? So this is somewhere here. This is first standard deviation. This is approximately second standard deviation. And the third standard deviation will be 500 and
5.4.
505.4. I believe this will be somewhere here. Right? Now, same thing on the other side. Okay. Now, the second curve will look more or less like this. I'll try to draw it as best as I can.
Sir, how did we consider this 501.8 and I missed?
Just 1 minute. You were saying something, sorry. How did we got 501.8, 503.6?
Yeah.
Right? This is just coming from here, the previous one. The sigma value was 1.8.
Oh, just added that. Okay.
Yeah, right. Okay. So for that, the distribution will look something like this, right? So now let me go back here. Okay. The same 495 was there. The same 495 is there. Here also it is 495. Where it is then? Right. This is also 495. This is also 495. Okay. The only difference is how the distribution has changed. Here, this was the distribution. This was the distribution, and this is the area which is less than 495, 7.78%. But now the distribution has changed. Why the distribution has changed? Because any idea why the distribution has changed?
Sample size is increased.
Right. Because n has become 200, right? Mu CLT will remain same as mu actual, that is 500. Sigma CLT has also changed to 1.8 I have taken. Right? Now, earlier, this was 7.78%, and I was saying that I don't have enough confidence to reject that the population average is not 500. But now, if you look at it, the chances of this happening, getting a value less than equal to 495 are very, very less, right? And that's the reason I was confidently able to say that mu actual is not equal to what is being claimed, right? Mu actual is less than what is being claimed. Because if this blue one is the distribution, then chances of me getting a value of 495 are very rare, right? Most probably that means that this is not the correct distribution. The correct distribution is something else, right? Now that something else can be anything. Like I'll try to kind of now explain it with a different example. Now, what people assume it that when I'm saying that mu actual is not same as what is being claimed, that is mu actual is less than 500 days, the people immediately conclude that mu actual is equal to 495, which is wrong, right? I don't know what the actual value is. All I know is that it is not 500 days. Okay, let me now try to the thing is that all I know that 495 is not like if 495 is coming from this distribution, then the chances that I will be getting a value as close as 495, those chances are very less, right? Chances of me getting 495 from this distribution are very less. But does that mean that my average is 495? No. Why? Let me show you. Okay, because I'm not sure why I'm not being able to select this. Right? Will it be, can it be this? Can it be this? The answer is yes, it can be this. Why it can be this? Because now the shaded area is this much. Now the shaded area is this much. Right? Can it be this? Yes, it is possible. Right? Let me show you what I mean. So let's say, can it be centered at here? Can it be centered at here? Yes, it is possible. Right? Is this possible that the average is 496? Yes, it is possible, right? Why it is possible? Because if it was 496, then this will be the shaded area. right? Which will be significant. Can it be, can it be, let's say, for example, this value? Yes, it is possible. Why it is possible? Now, this will be the shaded area, right? Again, the shaded area value will be much more than 500%, 5%. So this is also possible. So this is also possible, like a value of 496, a value of, let's say, 492, that is also possible. So I don't know which one is correct. All I know is that it cannot be, it is not 500, it is less than that. Okay, less than that, it can be 496, it can be 495, it can be 493. I don't know. Okay, but it is not 500. Okay. Any question?
Actually, I have a question, but not regarding this. Like, if our like null hypothesis get rejected,
Mm-hmm.
so like, what to do next? I don't know. Like,
There's
it got
nothing to do next, right? Like what, like you started with a question that whether it is less than 500 days or not. The answer is it is not less than 500 days, right? What you
like,
want to do with that answer, right, is something depend upon what business wants.
so like, how does this fit with our like our goal? I'm not like getting it. Like, this
Let's
is not
say,
like giving us the exact
right. Let's
result
say, for
also.
example, you are the manager, right? And you only make contracts with the companies where the average life of bulb is at least 500, which means that if it is more than 500, I'm happy, but it should be at least 500. I mainly only make contract with those companies. Now, after doing this exercise, I can go ahead and I can say that I don't want to do business with Xeon bulbs because their product quality is not good. So that will be my decision.
Okay, to like to set a benchmark, we use this.
Right, right.
Okay.
And sir, one question. Like, so we took three cases over here, right? And two out of three cases said that it is not 500. It has to be less than 500. So, is there
Right.
any ideal number of cases? Like, how many we should? How many
We
can be
should we
considered?
should we should try only one case, right? That's why I said all of these three cases are happening in three parallel universe, not in the same universe. Okay, we should take as big of a sample we can. If you
Okay.
can take a sample of 50, and you can take a sample of 200, always take sample of 200.
Okay.
All right. So I'm not trying these three things in the same universe. These three things are happening in three different universe. So I'm not conducting the experiment again and again in the same universe, right? So either you will be getting this, or you will be getting this, or you will be getting this, or you will be getting something else, right? I'm just telling you that, let's say if any of these things happen, then what decision you should take. Okay, if this happens, then I will be rejecting the null hypothesis. If this
Okay.
happen, I will
Understood.
not be rejecting it. If this happens, I will be rejecting it, and so on.
Okay. It's just one. Understood.
Right, it's just one.
So here, sir, if we are rejecting the hypothesis and we are saying that mu assumed is less than mu claimed. So will there be any cases where we can say that mu assumed is greater than mu claimed if we get percentage, p-value is very much more?
If your average comes out to be greater than 500, then you can assume it to be like for example, the problem statement was I wanted to either do business with him or not to do business with the Xeon bulbs, right?
Right.
So, to be very frank, I'm not interested in proving that it is more than 500 days. Because if I will prove it, like what the benefit I will get out of it? Maybe the Xeon bulbs will increase their prices, that because now I have proved that their product is better,
Okay,
right?
yeah,
So
got you.
I'm just interested in whether the quality is at least this much or not.
Okay, yeah, got you. Thank
Okay.
you.
So like according to this, like if we like fail to reject like null hypothesis,
Mhm.
so we should like stop like getting the result. Is it that?
We should stop getting the.
We should we should stop doing like in like the issue that we are like calculating. Should we like continue with it if we are like fail to reject the hypothesis that you are saying that we discussed like a few
Right, right.
five
So we will
seconds
be
back?
conducting only one experiment. If you fail to reject it, right, then you will be doing business with Xeon bulbs. But if you rejected it, right, then you will not be doing business with Xeon bulbs. Okay.
Yes, yes.
Now let me, you know,
So,
let me.
one question on that previous table size. So we are aware that choosing a small sample size uh, versus choosing a bigger sample size
Mhm.
deviate the results, and you can accept or reject the theory.
Right, right. Yes.
So in a real world, in a problem statement,
Mhm.
how will we conclude that what sample size I should take now? Whether
We
I,
should always take, like, this is the ground rule. Like, we should always take as big of a sample as I can. Okay. The 200 bulbs are better than 50. 1,000 bulbs are better than 200. 2,000 bulbs are better than 1,000. Right. So whatever you can afford to, right? The bigger the sample you will take, the better the decision you will be able to take. Okay. So in real world, whatever you can afford to do, you should do it. The bigger the sample you should take that
because
sample.
calculations will be uh, possible for any bigger number also. Like if I
Right. Yes. You can
2000,
take 1,000 bucks
you can
also.
take
Right.
1000 also. Still the
Right.
calculation is possible.
Right.
So if the sample is size is not given, and if I am there to choose the sample size,
Right.
so how do I define whether I need to take in this case, let's say 20,000 or 2000 or 200?
No, I'm just like the same thing, right?
Okay.
Conducting the experiment, let's say in this case, in the real life, going to a manufacturer, asking him to give you 2,000 bulbs, right? And then you will bring those 2,000 bulbs, you will plug them onto 2,000 different sockets, measure for each bulb when it is getting fused and all of that, right? It will require a lot of money, right?
Right.
So I want to do that, right? To be very frank, I want to do it, but that will require a lot of money and time, right?
Yeah.
And you are not dealing with just one manufacturer, you are dealing with many manufacturers. So let's say if I'm dealing with 10 manufacturers, right? So if I'm taking 2,000 samples from each manufacturer, that will become 20,000 samples, right?
Right.
So that is very unnecessary, right?
Got got
So we will try to take, let's say, as big sample as we can afford to do.
okay.
Okay.
Understood. Yeah. Thank you.
So
Yes, sir.
like if the sample mean is very close to our hypothesized mean,
Mhm.
so how can we like be sure the difference is real or just like a random chance? Because we
Yeah,
are just taking.
this is the probability of a random chance. So here it is telling you that the chances that it was 500, but I still got it 490. The chances are very less. That's why it means that it is not 500. Okay, so the chances that it is happening by chance is very less. This is nothing but probability of happening by chance.
So so the samples are like generated like collect randomly. So won't it like give us bias while we uh
Mhm.
the calculating like won't it create bias? I'm not getting it. We took the sample like the random numbers.
Right.
So
No,
for
random
each
number, you mean this random number?
no this
Huh.
in our sample size of 50 bulbs,
Right,
495,
right, right,
496, 500,
right.
504. So how can so it they were random numbers, right?
No, these are not random numbers. We have done the experiment and we got these values. Okay, obviously, like here, I cannot actually do an experiment and then put the numbers here, right? So I put it like assuming that these are the values that you are getting. This is the value that you got by doing actual experiment. The bulb one value was 492, 490. Bulb two value was 540. Bulb three value was 507. Bulb four value was this, right? Obviously, I have put it randomly here, right? But these are the values. I'm assuming that if you will do an experiment, this is the value that you are getting. So in real life, you will be doing the experiment and then noting down these values.
Okay. Oh.
Okay.
Like for example, if like I did the test and one bulb like was like very good, like
Hmm.
for example, uh, let's say that it was an outlier. So
Hmm.
will it affect our like final p-value, final probability?
Yes, a
Like,
little bit. Yes.
oh, okay. So if we have like bulb that that is giving us 400 days, and if we
Uh-huh.
have a bulb that is giving us 600 days,
Uh-huh.
so we should remove it from our sample or should we include it?
Depends upon how much of extreme value it is. Let's say, for example, one bulb you put and it immediately got fused, right? Uh,
Yeah,
don't you think that it is a valuable information for you,
it's
right?
valuable.
It is
Yes,
valuable, right? Because maybe the
yes,
quality of the bulbs are not that great, right?
yeah.
And maybe that's why it happened. There is a
Mm,
one bulb out of, let's say, 500 or 600, which is keep going, right? Let's say 1,000 days, 2,000 days, hypothetically, right? I know that it is
yeah.
just happening by chance.
Mm,
You got my point. So it is
yes.
based on the user discretion, right? You can take a call uh, like by yourself that what value you think are extreme and which
Mm.
values are you think are important to you and which value is something that you are ready to ignore.
So we can use the quarter formula also, no?
Yeah, we can use
To
it, right? We can use it. But again, as I said, uh, your in the real life, a lot of decisions we take based on the common sense, right? Not just based on some rule. So let's say, for example, if I try to explain this quarter formula, this and that to the business, they might not be able to understand it. They will just simply say that you see that there are four bulbs that as soon as I switched on the switch, it got fused. Why you are removing it? And it's very difficult to explain. And to be very frank, my common sense also says that we should not remove those data points from the data,
yes, I was
right?
also thinking like that we should not remove the default like
Right. So the
that bulbs.
1.5 interquartile range formula that you are talking about, that is something, to be very frank, uh, is not a rule, right? It is just one of the way of doing it. Like, but should we always do it like that? The answer is no. I said this thing when we discussed it, the box plot as well, right? That this is just one of the way of handling or identifying outliers. This is not like the ground rule that this is the only way and this is how it should happen. With outliers, you need to take your own call whether you want to keep it in the data or you don't want to keep it in the data,
Now I got it. Thank
right? Any other question? Anyone? Okay. Now we'll just simply write down like the steps that we take in general when it comes to hypothesis testing. Steps to solve hypothesis testing. questions, right? The first step is, right, we need to define what is our null hypothesis and our alternate hypothesis. How do we define that? The equal to one will always be the null hypothesis, and the other one will always become the alternate hypothesis, right? Always. The equal to one will be null hypothesis, and the other one will be alternate hypothesis. Okay, that is one thing. That will be the first step. So you will define the null and alternate hypothesis. Second thing that we will do is, once you have defined null and alternate hypothesis, we will assume the null hypothesis to be correct and solve the question using, what do we use? Using central limit theorem. Okay, we will assume the null hypothesis to be correct and solve the question using central limit theorem. Okay, third step will be, using central limit theorem, you will get probability. P-value. Okay, using central limit theorem, we will calculate the p-value. Fourth step is, if your p-value comes out to be greater than alpha, right? If it is greater than alpha, we will be what? Accepting the null hypothesis or rejecting the null hypothesis?
Accepting.
Accepting it. Accept the null hypothesis. If p-value is less than alpha, then I will reject the null hypothesis. Okay, so in general, we accept and reject the null hypothesis. The alternate hypothesis will always be the opposite. If I accept the null hypothesis, then alternate hypothesis will get rejected. If I will be rejecting the null hypothesis, then alternate hypothesis will get accepted. Any question?
Can you add the sample size relation in these steps?
Okay, okay. I can just add like here. Take as big sample as possible. Okay, whatever is possible, that much big sample we should take. Right? Once you have taken the sample, your n will be fixed, the small n, right? And then you can use it, central limit theorem. Okay, one last thing before we conclude the class. alpha, which is also, I was saying that is a threshold. For accepting and rejecting the null hypothesis is also equal to probability of type 1 error. Okay, I will discuss next time what type 1 error and type 2 error is. Alpha is the probability of type 1 error, and 1 minus alpha, right, is called confidence interval. Confidence level, sorry, not interval. 1 minus alpha is called confidence level. So in general, we take 5% as a value of alpha, which automatically means that we have 95% confidence level. It means that whatever the conclusion that we are making, okay, if we are rejecting the null hypothesis or accepting the null hypothesis, I am at least 95% sure that the decision that I have taken is correct. If I'm saying that the average life of bulbs is less than 500, I am at least 95% sure on that. If I'm saying that the average life of bulb is most probably equal to 500, then I am at least 95% sure on that. Okay. So confidence level is nothing but 1 minus alpha, which tells me that how much confident I am on my decision making here. Okay. Now in the next class, what we will be doing is the same way we have solved question for xenon bulbs, right? We will try to take similar examples. Let's say the next question that I have is, let's say there is a school in which a lot of students are studying, and the principal is claiming that the students who study in his school have relatively higher IQ as compared to the rest of the population, right? So we will try to check whether this claim made by the principal is correct or not. Okay, so again, something which is a very real life problem. The other questions that you can solve using hypothesis testing is, for example, Bonvita or Complan, whatever, right? Let's say the Complan is claiming that the students or the children who drinks Complan are relatively taller as compared to the rest of the population, right? This question can also be solved using hypothesis testing. Okay, or the other thing, let's say the people who is taking coronil have a higher chance of surviving corona as compared to rest of the people. Right? So any claim that you make, any claim in this world, any claim that you make, right, can be tested using hypothesis testing. Okay, and we will try to pick a few more examples in the next class. Before that, my request will be try to go through these slides, right? And if you have any question, we will start with that. If you will not have any question, we will jump on to other question and we'll try to solve it. Okay. That's all for today. I will see you guys next time. I have already shared yesterday's class PPT in the shared drive. I will also share this class PPT as well, and I will see you next time. Bye-bye.
Thank you, sir.
Bye. Thank you.
Bye. And I know next week it will be like, I believe the Holi is very close to those classes, right? So most probably we will be having the class, but let's say if there are enough number of students who doesn't want to have a class, then we might cancel it. Although I would like to have it if possible. Okay, but just giving you guys a heads up.